The recording has started, and my plan for today is similar to what we have done the previous couple of lectures. There will first be some information here in the beginning from me, and then after that we're gonna take a look at the quiz that you guys did for today. And then before you start working on today's tasks, there will be an example from me too. And this example is maybe a little bit bigger than we have had before, but we will come to that in a little bit. First, some information. And for all the tasks that you will hand in now for task 2, or all the problems that you solve for task 2, which has a deadline on Sunday, the 17th of October. So for all those problems that you solve, you will have to use the command line. And there is a post in our discussion forum named how to use the command line. In there you can find some information about how to use the command line, and then under each task there will also be a link to a video where you can get some more information about how to use the command line. And also for these tasks you should be using the if name equals main that we have talked about last week, and I think the exercise before that we also talked about it. So remember to use the if name equals main in your scripts when you hand in for task 2. And there should also be under each task there is a link to a video where you can get more information about this. So hopefully that shouldn't cause any troubles. I just want to remind you that you should use it. And continuing talking about those problems that we have for that examination, there is the one that gives 3 points. For that one, you need a main function that kind of drives the script, that asks for how many kilometers you want to check. So you can check the video to see how it's supposed to work. So it just remind you that you need the main function in that one. And one thing that I've got a few questions about is that in one of the example videos, I use a command called less to show the content of the file before I actually run the Python script. This less command is used to show the content of a file, and it's available on a Mac or if you're running Linux. And that part is not part of the task. So it's just me showing the content of the file. So maybe it's a little bit easier to follow along when I then later run the Python script. And for you guys, you don't have to worry about that less command. What you should be doing is creating the Python script. Let's see. And there is one last thing about the examination that I've written down that I should mention, and that is for the task that gives 5 points. In there it says that you should develop a bubble sort algorithm, and the idea here is that you should write the code for that sorting algorithm. So you shouldn't use the built-in sorting that you read about for today in the book. So you should write the code for the sorting algorithm yourself. And to be more precise, it's worded as it's a reverse bubble sort. So it should sort in the reverse order. And don't forget the deadline. As I said, it's on Sunday. So don't forget that. But enough of the information about the examinations, and let's jump straight into the quiz that you guys did for today. And I find it a little bit interesting to look at the statistics. So for today, it was 81 of you who choose to do the quiz, and that translates to roughly 59% of the number of registered students in the course. And the number of registered students fluctuate a little bit throughout the course, but today, using today's numbers, it was roughly 59% of you guys who choose to do the quiz. And looking at the average, you got on average 89% correct answers, which is really good. And if I compare it to before, it was roughly the same amount of students who did the quiz this week as last week. But these 2 last weeks, there have been a few students fewer than the weeks before. So I just want to say, don't lose the momentum here in the end of the course. I know that the quiz is not mandatory, it's optional, but it kind of gives an indication of how much you guys are working. So I just want to say that don't lose the momentum, keep studying. We're almost at the finishing line, and remember, study full-time these last couple of weeks too, and it will work out. And if we look at the questions for today on the quiz, there was one thing that stood out as a little bit problematic, and I was thinking that I could show it in Visual Studio Code. So just give me a second and I'll share my screen here. And that one question that caused a little bit of problems was the one where we had negative indexes. So let me just first create a list. So let's see that we have, for example, Anna, Kalle, and I think we have used Max as the third person here. So if we have a list with 3 names in it and we want to print them, we could do something similar to what I will do here. I won't use a loop to start with. Instead, I will print each index individually. So we could do something like this. We could say that, all right, what can I find at index 0? Well, there I'll find names 0. And then I'll just copy it for index 1 and 2. And if we run this, let's see what we get. Maybe it's not a big surprise that we get that Anna is located in index 0, Kalle at index 1, and Max at index 2. But now let's transition into the negative indexes. So we'll keep this on screen here, and I'll just add a divider. And then we'll do print. And let's see if we do, what will the negative index 1 gives us? So if we say that, all right, let's print whatever is at negative index 1. And if we run it, we'll see that it prints Max. So the very last element in our list. So we can start to guess that, all right, -1 means the last element. And if I add 2 more, let's see if we can print all the names using negative indexes. And let's run it again. We can see that, all right, -1 is Max. And then if we go -2, that would be the previous one. And then yet again, -3, one more previous one. So that's the first one, Anna. So using negative indexes, we start in the end of the list and we work towards the beginning of the list. So -1, -2, -3. And note here that when we start at positive indexes, we start at 0. So the first element is 0. Anna is 0. But when we start from the back of the list, the last element is -1. So it's not -0 or something like that. It's -1. So we just have to remember that. So -1 and then decrease by 1 when we're going to the front of the list. And here we can also create a loop. So we'll add one more divider here. And we can create a for loop too. So for I in range -3, 0, and what should we do? We should print names I. So we say that, all right, start at -1 and work up to 0, but do not include 0. Remember, range start is inclusive and end is exclusive, meaning that in this loop, I will get the values -3, -2, and -1. And it will print, if we start at -3, we see that, all right, -3 is Anna. We have written it here before, but if we look at our list, we can see -1, -2, -3. All right, so it will print Anna first. And then when it comes to -2, that's Kalle, and -1 is Max. So just remember that negative indexes start from the back of the list, and then it starts at -1 for the last one. All right. Niklas, any questions so far?
No, nothing special, no.
All right, good, good. Then let's continue on to what I would say is the main part of today's lecture, and that is the example that we're going to work with. That's going to take up the majority of the time here. And what we're going to do is that we're going to continue to work on the script that we developed last week. I will quickly go over it and just on a general level say what we did. But if you have any questions or if you don't remember how everything works, I would recommend to later on go back and watch the video from last week. But if we look at the script to see what we ended up with last week, we had two constants where we had the file names that we used in the script. Then we had one function, read records, where what we used with as to open a file that will automatically close for us. And then within this block that belongs to the open or with open, we read the file. First we read the name, and then as long as the name was not empty, we also read a number of bugs that that developer had introduced. Then we printed it to the screen and read the name of the next developer. We also had some error handling here. And maybe we should take a look at this bugs file that we were looking on, because what we had in here was the developer's name, and then on the next line we had a number of bugs that that developer had introduced in some software that they were developing. So one record in the file is 2 lines, the name, and on the next line we had the number of bugs. All right, so that was one of the functions that we developed. And then if we continue to look at the next function we did, in this function, the aim was to supply a developer's name and then increase the number of bugs that that developer had introduced and write that to the file. And we did it in a similar way. We used with to open 2 files this time, one for writing and one for reading. Then we had a similar loop where we looked at one developer after the other. We read how many bugs they had introduced, and If it was the developer that we were looking for, that we sent in as a parameter, we increased the count by 1. Then we wrote it to a temporary file, and we looped around here for a bit until there were no more developers, and after that we removed the original file, and then we renamed the temporary file to the original file's name. So that is an overview of what we did last week, and now let's continue working on this one. And for today you have read about lists and tuples, so maybe it's not a wild guess that that is what we will be introducing here, and we will work on these functions. But before we start the example, I just want to mention that this will probably be a little bit more code and a little bit more stuff to grasp than we have had in the previous examples. So please just ask any question that you might have in the chat, or try to follow along and then know that it is recorded, so you can go back afterwards to look at the video. And also, I got a question from the Swedish group this morning if I could also post the code later. So I will do that too. I will post the finished code that we will end up with. I will post that on Canvas under modules, and then in the very bottom of the modules page there is activity recordings. I will post it under there later today. But enough talking about that. Let's look at how we can change this to have tuples and lists in it. And the first thing I'm going to do is that I'm going to go to this file where we store the records of how many bugs each developer has introduced. And instead of having 2 lines of code, I'm going to change it so that, alright, we're just going to use 1 line in the file per developer. And we'll say that, alright, first we have the name of the developer, then a colon to separate the next part here, which is how many bugs that developer introduced. So we can see it as 2 elements divided by a colon. Alright, let's save that. And then if we go back into our script, I think what we will do to start with is that we'll go down to our main function, and we will comment out that we should increase the count every time. We will wait with that function till a little bit later. For now, we will only focus on getting this function to work with the new format in here and with lists and tuples. So let's see what the first step should be. If we look in here and remember that we had 2 lines before, but now we only have 1 line per developer. So reading the name is not what we do if we read 1 line. I will rename this to call it line. So 1 line is both the developer and the number of bugs. And I will also say that, alright, continue as long as that line that I read is not empty. So I just rename it to better reflect what is actually in the file. And after that, somehow, now we have the information in 1 line, as we have said. Somehow we have to get hold of that information. So we have to split it up into 2 parts. We know that they're divided by a colon, so let's see if we can split that into 2 parts. And we can, of course, do that. Something like this, maybe. And if we take it slowly and just look at what we did on this line of code here, if we have a string, which we have read 1 string from the file that looks like Anna:5, for example. If we take that, we can use a function called split. And then we can supply a string telling what to split on. And what this means is that Python will look at that string that we have and create a list with elements from this string and separate it by the colon. So that means that from this, what will happen? We have Anna colon 5, but what split will return is a list where each part or what each element is separated by colon. So it would be something like Anna, and then there's a new element in the list, which is 5. So we see that we get these two elements from this one line. There is a colon separating them, and we say that, all right, split on the colon, which means that we would end up with these two parts. So that becomes a list which is stored in this variable parts. And now we know that, all right, we don't need to read the bugs on the next line because we already have them. Remember, we had one line. But something that we have to change is this part here where we print it. Because before we had two variables, name and count. Now we only have one list, which is called parts. So here we will change this to parts. And the first part is the name. You can see here the first part is name, and the second part, or the one at index 1, will be the number of bugs introduced. And we still have to read the next line of the file. So we read one line, and as long as it's not empty, split that into a list and split on the colon. So we end up with something like this. Then we print it to the screen and we read the next line. And we can, of course, try to run it and see what happens. And we can see that it has managed to use this new format that we have in our file to print it to the screen. And we are now using a list. But we can of course make it better. So let's see, the next step would be to try to improve what we have in here, so maybe it becomes a little bit more readable. Let me write the code, and then after I've finished writing the code or changing the code, we can talk about it. And before we talk about it, let's try to run it so I didn't mess up. Oh, it seems to be working. But as a parenthesis here, before I talk about the code, when I did this example for the Swedish group this morning, I made a mistake here. You see that I've written rstrip, but when I did it with the Swedish group, I wrote rsplit instead. And I didn't see that problem right away. And that is something to remember. Sometimes when we write code, we are so focused on what it should do that we actually don't read every part of the line. Because in our head, we know what we should write here. So we don't read it, we don't see the mistakes that we make on every line. So that is something that we could remember for the future, that even if we think a line does something, sometimes we have to be really careful to actually read what we have written on each and every line. But all right, this time I managed to write rstrip instead of rsplit, so it worked without a problem. So what did we do here? We changed the while loop to a for loop instead. This way, we don't have to read the line from the file twice. Instead, we will go over each and every line in the file. And what do we do in the for loop here? So it will provide us with one line at a time, and each time with every line we remove the new line character. We do the same part here where we split it to a list, and then we print the two different parts. Niklas, are there any questions so far?
No, not really. It was just one about rstrip and strip, the differences. And I just wrote that the rstrip is looking from the right, like taking away the trailing characters. And you have the lstrip as well. I don't know if that's how much. I mean, you can basically use strip here as well. But rstrip, I mean, I'd assume that's more readable to actually point out that it's at the end of the string that we want to remove it.
Yes. So I like to be very explicit with I'm removing something from the right-hand side and I am removing the new line character. You can be more or less specific here, but you will see me be very specific about it. But yes, you can also remove from the left-hand side with lstrip or from both sides with strip. But all right. Then let's see what we can do more. Because if we look at this function that we have here, read records, we are doing more than one thing. We are reading from the file, we are printing to the screen, and we also have our error handling in here. So we are doing several things, and we should try to create our functions so that they have one purpose. They do one thing, and they do that one thing very good. And as we just saw here, we're doing three things. So let's see if we can make this function do one thing. And I'm thinking that we should change it so that it reads from the file. And then it would use a list to return whatever it read from the file back to whoever calls this function. So we will change it to only do one thing, and it will return a list. So, all right, the first thing we need, if we're going to return a list, let's create a list that we call developers, and it's empty to begin with. And let's see, we could remove the try and accept. We'll have that somewhere else. But for now, we leave it to be done later. For now, we're just focusing on this one function. And what are we doing here? We are opening the file, and then for each line in the file, we should do something. But I'll do this. Give me a second here, and I'll just write the code, and then I'll explain it afterwards. So, all right, it looks completely different, I would imagine, but if we take a look at what we did here, and let's discuss each piece here. So we said that we created a list, which is empty to begin with. Then we open the file, and we still calls it bugs file. Then we go over all the lines in that file. So far, so good. But what are we doing here? So what we are doing here is, if we take a look at the right-hand side, we are still splitting a string. So if we look at what it would be, if I write it here again, it would be something like Anna 5. So we are splitting on the colon, so we end up with a list with 2 elements. And now here we will use something called list unpacking. Because we see here on the left-hand side, I have two variables equals to this list that we get from the split. What that means is that we will unpack this list of two elements and put it into these two variables. And here we have to note that we have to have the same amount of variables on the left-hand side as we have elements in our list. But we know for sure that we will have two elements because we are in control of this file, and we know that on every line there will be two parts, the name and the number of bugs. So we will end up with something like this, which means that I can use list unpacking to get it into two variables. And what do I do with those two variables? Well, if I just temporarily do this, we can see that the inner part here is that I am creating a tuple consisting of these two elements, of these two variables. So a tuple where the first element is the name of the developer and the second element is the count of how many bugs they have introduced. What are we doing with this tuple that we create? Well, we add it to the developer's list that we created before. So we append it to the list. And we loop through the file, read all that information, create the tuples, add them to this list of ours, and then finally we return it. So we return this list of developers that we read from the file. All right, but if we return it, we have to be a little bit careful because we call the function down here and something will be returned. Where should we store what is returned? So we have to remember to add some variable where we will store the result of calling that function. But we removed a few things. We removed printing to the screen, and we removed the error handling. So if I now made this function that just reads from the file, I have to create a new function that is responsible for printing the developers to the screen. So here we read them, and now let's create a new function. Let's call it display bug count. And if we're going to display all the developers and the bugs that they introduced, we need to send that as a parameter, or we need to send it as an argument to this function. So we need to add a parameter here. Let's call it the developers. And we need a loop to loop over all of them. And we should print it somehow. Let's see if we can create some nice way of displaying it here. Developer, and we have index 0 is the name, has introduced, and then you need developer. Index 1 is the amount of bugs. Let's see here. Anna has introduced 5 bugs. Yeah, so that looks like we have some fairly similar output to what we had before. If we call this function, that is. So let's go down to our main function again. So we read the file. The list of tuples that we got back is stored into developers. Now let's call our new function and supply that list of tuples. And let's see, we called it display bug count, and I want to send along developers as the argument. And it's always exciting to see if it runs after I have changed the code. So let's cross our fingers and hope that it works. And we see that, yeah, it kind of worked. We got a new line here. So somehow we missed something here. And actually, I think what we want to do is to say that, all right, when I read it from the file, it is read as a string, but I actually want it as a number. Especially if we think forward a little bit, that we want to increase the number of bugs that a developer has introduced, and I want it as a number instead. So let's see if we try to run it again. We see that, yeah, now it looks much better. Now we don't have that new line that we got here up before when we splitted it. All right, so we have introduced a new function which is responsible for printing all the developers to the screen. And here we have our read function. If we look at them now, we can see that they are much cleaner. Each of them have one responsibility. So if we imagine that we would like to change the format something is printed to the screen, we know that we only have to change it in this function, and that would do the trick. And if we in the future decide that we want to change the format in the file, we know that we should look in this function, and we know that this, all that it does is read from the file. So if we change it here, then it will work in all the places where we read it. There is one thing that we could do, let's see if we can find it here. We see this one here. When we display it, we get each developer, so each tuple, we get one tuple at a time, one for each developer, and then we use the index to say that, all right, this is the name and this is the number of bugs that we have here. But maybe we could use something similar as to what we did before with unpacking. We used unpacking up here. Maybe we could use something like tuple unpacking here and say that, all right, instead of getting the tuple back, I know that I will get a tuple one at a time, but unpack it for me so that I get two variables instead. Then I can make this output a little bit easier to read by saying that, all right, I want to first print the name and then count. So it becomes a little bit easier to read, even if we don't know the format, what is in which position here. Is the bugs first or is the name first? Even if we don't know that, by looking at this one here now, we see that, all right, it will print the name first. We don't have to worry about the index that we had before. So that is one thing that we could do, to do a tuple unpacking. All right, and as we change something, let's just try to run it and make sure that I didn't break anything. I didn't. So far, so good. And I think the next thing that we will do is that we will start working on this function here. Here is a lot going on in this function. We are opening two files, and we are reading from one file, and we are writing to another file. But we're also updating the count here for the one developer that has introduced a new bug. So there is a lot going on in this function, and hopefully we can make it a little bit simpler. So give me a second and I will rewrite the code in here, and then we will look at what we end up with in the end. But before I rewrite it, take 1 or 2 seconds just to read the code in this function, so you have an idea of what we are doing in here. All right, so what we did here, as I said, we had two files. We had the original file and we had our temp file. But now we have already read all the developers and we have them in a list in our main function down here. So why don't we send them along as an argument in here? Then we don't have to read them from the file again. So I think that is the first thing that I'm going to add here. I'm going to add that we're going to send along that list of tuples. And then let's begin with changing the code in here, and I'll do the same here. I'll change the code and then we can talk about it afterwards. All right, let's have a look here at the changed code. So remember, now we're sending in a list of tuples with all the developers, and we're also still sending in the name of the developer that introduced a new bug. What are we doing in here? Well, we're opening the temp file for writing, and then we're looping over our list of tuples, and we use tuple unpacking to, for each element in the list, we get name and count. So that is the two parts from the tuple. And we use that to say that, all right, if the name of the current tuple, that means either Anna, Kalle, or Max, if that is equal to the developer who introduced a new bug, and we know that by looking at this parameter here, is that those two equal, then increase count by 1. And after we have done that, we write it to the temporary file. And here we have a new format in our file bugs.txt. So we must change how we write it to the file. And in this case, I changed it to an F string where we have the name, colon, and the count of bugs, and then a new line. And remember that count is updated for one of the developers. Then the last part here is the same. What we're doing here is that we're removing the original file, and then we're renaming our temporary file to the original name. So we can see that we got rid of having to open two files. So we are only opening the temp file now. But all right, if we have changed this one, we can also see that, all right, for it to work, we have to uncomment it down here. And actually, that is not enough, because we are sending in the list of developers that we read in our new read records function. So we also have to move this one to here. So we first have to read that information that we need as an input to this new function that we created here, or rewritten function that we have here, the increase count. All right, let's see if we run it, what happens. So we see Anna has 5 bugs, Anna has 6 bugs, 7 bugs, 8 bugs. So we can see that it's working. We can now write to the file. We see they look a little bit more streamlined, these functions that we have here. But there is one thing that hurts in the eyes a little bit when you look at this script. And that's the part that we have up here, that we have hard-coded the path to our files. Because as it is now, if we were to have another file, another bugs.txt file, containing developers' names and how many bugs they have introduced, maybe for another project that they're working on, if we want to use this for that file too, we have to change the name here in the script. So we have to rewrite the script if we want to use more than one file with bugs in it. And we can do better. So that is what we're going to change next. And we're going to do this by using command line arguments. So whenever we start our script, we are going to supply the files that we need to run the script. So we supply the full path to the files, to the text files. And you will be using command line arguments for the tasks that you hand in, or for the problems that you hand in for this task 2 that has a deadline on Sunday. So let's see how we can do that. But I think before we jump into and do that change, what we will do is that we will add back the try excepts that we removed before, so that we have some error handling. And I'll add them back here in main. So we have our functions that are specialists on doing what they are doing, and then I will take care of the errors in the main function. So I'll add back try and except in here. And we had something like a file not found exception, and we printed some message so that the user know what went wrong. We had error, there was a problem accessing one of the specified files, or something like that. And we also had a value error, if I remember correctly. And here we can say something like error bugs must be specified using integer numbers. Something along these lines. So we have added back the try excepts here. So we didn't lose them. We just moved them to the main function, so that these functions are more specialized on what they are doing. All right, but if we have done this, and before we add code in here to take in these as arguments when we start the script, before we do that, I think it might be a good idea to just try to run this script as it stands now from the command line or from the terminal. So I'll just change and share my full screen instead. And we can create a terminal window. And what we will do now is that we will navigate to the directory where we have saved our script. And this is probably the command that you will be using the most, if not, it's one of the 2 commands that you will use now that you will use this. So if I say that you will use it most often, it's together with running the script, because those are the 2 things that we need to know how to do now. To change to another directory where we have stored our script. And I know that when I start a terminal, I start in my home directory. So I need to navigate to the desktop where this script is stored that we are now working on. So cd desktop. And this command cd means change directory, and here I can supply a directory I want to change into. And we see if I do, it goes to my desktop directory, just as if we did it in Finder or in the Explorer, the File Explorer. But it might be tricky to know where this directory is that you have stored your file, or your script. So I'll go back to my home directory, and I'll show that you can do something similar to this, where you say that, all right, I want to change into a directory, and here you can supply the full path to that directory. And my full path would be something like this. But on Windows computers, it would be something like cd c:/ my files / and where you have your files. So it's the full path to the directory where you have stored your files. And when we are in this directory, so we have used one command cd to change into a directory, and when we are here, we can use Python to run a Python script. And this one that we have been working on is main English. And we see if I run it, it will run my script out here. But the next step that what we will do here is that we will start our script from the command line, and we will supply some parameters here. So here, instead of my random characters, we will supply the path to the file that contains our bugs. So that is the aim of what we need to do. But of course, to do that, we have to go back into the code and make some changes in there. All right. So, as I said, we need to make some changes, and maybe the easiest thing to do is to first get rid of these two constants that we have up here specifying where our files are. Because these are, of course, specific to my computer, and if we can get them to command line arguments, we can supply whatever path that is on the computer where we're running the script. So let's just get rid of these. And we see that, all right, in a few places in the script now, we get errors because this is where we use the constants. So for this to work, we have to supply those paths to the functions. So what we can do is that we can add a new parameter, bugs file name, I'll call it. And instead of using that constant, we'll use that parameter, bugs file name. So we see that, all right, send in the name or the path to that file that contains the bugs. That is the one that we are opening here. And we will do this a similar thing down here in this function, but here we have to send along two paths, one to the bugs file and one to the temp file. So maybe something like this. And here we have the temp file, so that should be the parameter temp file name. And down here we have bugs, okay, bugs file name. And here we first have, all right, rename the one that we send in as temp file name. And it should be renamed to the path that we have in the bugs file name. So we see that, all right, we remove them up here. Instead, we are sending them in as arguments. The file names is sent in as arguments to our two functions here. But all right, then we have to supply them down here too. Somehow in our main function, we have to get hold of, if I, for example, write bugs.txt and temp.txt here, if I do something like this, somehow in my script, I have to get hold of these two file names or path names that I have here. All right, so how should we do that? Well, there is a module that we can import that is named Sys. So the Sys module will help us with this. And I'll write a little bit of code here and then we'll talk about it. So give me 1 second here. All right, so after having imported this module named Sys, what did I do down here? Well, let's start with this part here. Here we are grabbing those two paths that we are sending in here, these two file names here. So sys.argv1 will give me bugs.txt. Sys.argv2 will give me the next argument that I'm sending in here. And then you might wonder, all right, this looks like it's a list, but why are we starting at index 1? Well, that's because index 0 is the name of the script that we're running. All right, so let's see, that is this part. Grab those from when we're starting the script, and then we also need to have these in the else. So get that information from the command line, send it along to our two functions that we created before. And all right, but what is this part here? Well, I'm saying that, all right, if we don't get the number of arguments that we expect to get, then what we will do is that we will give the user some hints of how to use our script. So we say that, all right, if they don't supply these two paths that we need to run our script, then we will say that, all right, you use the script this way. You started by running Python, the name of the script, and then you have two paths that you supply. All right, so if we save it, we go back out here and we do Python main English. We see that, all right, I didn't give any arguments here for what files to read and use. So then it will tell me, all right, to use this script, you have to write it this way: Python main English.py, and then supply these two files, the path to bugs.txt and the path to temp.txt. All right, I'll do it this way, I promise. Main English, and then we have these two files, bugs.txt and temp.txt. So let's see what happens if I use it this way. And if we run it again, we see that it's working as it should, and we supplied the file names to use as arguments from the command line. This means that if we tomorrow have another file with bugs in it, we can change the file name and run the script without changing the code in the script. It will work on that new file with other developers and another count of how many bugs they have introduced. Something to note here is that I just wrote bugs.txt and temp.txt, and that is because those files is in the same directory as where I'm starting my script. But if they are somewhere else on my hard drive, I can supply the full path to them. So my script can be in one directory and my text file somewhere else on the hard drive. So I can say users, I can give it the full path, desktop, and it was bugs, and I can give the full path to the second one too. Yeah, so that you know that they don't have to be in the same directory for this to work. And we see that, all right, now it's still working with the full path to where that text file is located. All right, this has been somewhat lengthy examples, and we have changed it a lot so that we are using tuples and we're using lists, which you guys read about for today. And I think I will end this example here so that we still have some time for you guys to ask questions and you can start working on the tasks. But before we end the recording, there is one thing I want to point out, and this is kind of like an extra task for you guys, because what we have here is, if we think about what we are doing, we are using this function read records to read the content of this file. And we are creating a list of tuples which we store in developers. Then we call this function increase count, which we have here. And we can see what we're doing in here is that, yeah, we are opening in a temporary file. We are looping over the list of developers. For one of them, we are changing the local variable count to add one more bug. And the emphasis here is on the local variable count. Then we write that to the temporary file, and then we remove the original and change the name of the temporary file. Alright, but then we go back here in main and we see that the next thing that we do is that we are still using this list developers to display the bug count. Here we actually have introduced a bug, because what we have here is reading the file, and on this line we are updating the file with the new count where Anna has one more bug. But then what we are displaying on screen is the bug count before we updated Anna's count. Because remember what we said here, this is just a local variable. We didn't update the list. So the extra task is to see if you can figure out a way of solving it. And I'll give you some hints. Because there are a few ways you can solve it, but one way would be to split this function into two. Because what we're doing in here now is two things. We are both writing to a file and we're updating the list. So maybe if we can split it into two functions, one that updates the list of developers and give Anna one more bug, and we have one function that just writes to the file. Then we could, down here, read the records, update the list of developers, and then we could display it, or then we could write it to the file and then we can display it. So that would be one way you could approach that. Another way would be that, all right, if we read the developers here, we increase the count so that we update the file. Maybe we could read the file one more time before we update, or before we display the bug count. So that is two different approaches that you could take to solve this little bug. But I'll leave that as an extra task. It's been a long example, so I think it's enough there. I'll stop the recording. Just give me 1 second here.